I'd like to continue on with this right here about, I'm on number 9 right now. Can muscle cells regrow? Now, I apologize, I don't have enough space for an answer between each of these questions. So you're going to have to copy down the question or the number of the question and your answer, okay, when you return this to me. All right, please do that. Can muscle cells regrow? Well, any tissue can regrow if there's something called a stem cell there. Stem cells are present probably throughout the body, probably in every tissue. We don't know. For instance, the nerve cell has no stem cell that we have identified yet. So we think when a nerve is damaged, it does not regrow. Well, a skeletal muscle has a stem cell called a satellite cell, S-A-T-E-L-L-I-T-E. A satellite cell is a stem cell in a skeletal muscle, but it's not activated. When a muscle is damaged, it will not regrow. Now, there have been some treatments with some electrical stimuluses, some really small currents, microamps, to stimulate muscle cells, and they've had some success with it, but nothing major. Okay, so the answer is probably not, although there are satellite cells, stem cells, and skeletal muscles. I will look for that in your answer. Okay? Muscular dystrophy. Well, there's a problem in the protein. I don't have the protein listed up here as far as the connective tissues right there. I don't have tropomyosin, troponin listed right here. There's a protein called dystrophin, D-Y-S-T-R-O-P-H-I-N. Dystrophin connects the myofilaments where the sarcomeres are to the muscle cell membrane. And actually some of the proteins go through the membrane to the endomyosin. So it's a connection between the myofilaments where the sarcomeres are to the cell membrane and the endomyosin. Now this is a fairly complex protein. Matter of fact, about 1% of our DNA codes for dystrophin. It's a hellacious protein right here. It's got a lot of subgroups. Okay, so when there's a problem in making the protein right here, there's something called muscular dystrophy that develops. The force that is exerted by the sarcomere, nothing wrong with the sarcomere itself, but the force exerted by it is not transmitted to the tendon, to the covering around the bone. It doesn't work that way. So muscular dystrophy is a problem with muscles, problem with dystrophin, which is a protein that connects the filaments through the sarcolemma, through the muscle cell membrane, to the endomyosin. That's what I'll be looking for. Okay? Clubfoot. Clubfoot is when the soles of the feet oppose each other. If these are the soles of my feet, and I can't show you this anyway, these are the soles of my feet, the soles of my feet will oppose each other. Well, a baby is born that way, but they don't stay that way because when they walk, when they learn to walk right there, the feet straighten out due to bone growth, due to muscle growth right there, due to tendon growth, due to connective tissue growth right there. The bones, the joints will straighten out. In clubfoot, they don't. In clubfoot, the babies are a year old, 2 years old, and they can't walk because the soles of the feet oppose each other. How common is it? About 1 in 1,000. About 1 in 1,000 have it right here. So the treatment is cast. Soft cast, hard cast. The treatment is cast. You cast it, you turn it, 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 and you cast it. And then after a series of casts, it probably takes a year to do this right here. Then the feet have been made to go to their normal position right there. But if you don't do that, right there, then the feet will never do that, and they oppose each other, and the kid will never walk. Okay? That's what clubfoot is. Okay? Now that's just a touch on skeletal muscles right here. Let's take a look at some bones for a few minutes. I won't finish this today. I'll finish it Monday, and I'll get it on the web Monday right here, okay? And I'm not going to do anything tomorrow, which is Good Friday. List 4 ways that bone can be classified, include examples right here. Well, I probably should have said bones classified based on shape. And I ought to go get a skeleton right here, but I don't have one. I do have one, I just don't have it in here. Give me a few seconds to erase this right here. We'll talk about bones, all right? All right, bone shape. Bone shape right here. We have long bones. Long bones. Or the tibia, the femur, the radius. Oh, no, I don't really care. I'll write down femur. You can write down any long bone that you want. Femur. Short bones. Short bones. Phalanges. Shorter bones right there. Phalanges right there. Finger bones. Phalanges. Flat bones. Flat bones. Okay. Skull bones are kind of flat. They got a little round shape to it, but they're mainly flat. Skull bones, all right? I can write down skull bones. Or you could write down the scapula, or the sternum is a short bone. It's a flat bone. The sternum is a fine example of a flat bone. Sternum. Only want one example right there. The skull bones or the sternum or the scapula. And then there's something called that we call irregular shape. Irregular shape. These would be the vertebra, the bones of the spine, all right, the spinal column bones, the vertebra, the V-E-R-T-E-B-R-A, V-E-R-T-E-B-R-A, the vertebra, okay? Now that's 4 ways to classify bones based on shape. Give an example, okay? Now, draw and label a typical long bone. I'll do that one. Let me do the next one and call it quits for this morning. But let's take a look at a bone. Let's take a look at a long bone right here. Now, all bones are going to have these parts, but it's easier for me to show you the parts of a bone when I draw a long bone, okay? Now, this will be something to behold, something to show your grandchildren. Well, I wouldn't do that. But anyway. That's somewhere in the animal kingdom, but maybe a bone looks like that. It's a long bone, okay? Now, it's got several different parts, and this is what I'll be looking for. If you can't draw the parts, at least list the parts that we have right here, okay? Now, the ends of the bones articulate with another bone right there. There's a joint right here. There is cartilage on the ends of the bone called articular cartilage. The first thing I'm going to put up here. But I'm going to put a little red articular cartilage up here. Articular cartilage. Articular cartilage. A-R-T-I-C-U-L-A-R, cartilage. C-A-R-T-I-L-A-G-E, articular cartilage. And that's the red stuff that we have right here, okay? So sometimes when this articular cartilage degenerates, you got degenerative joint disease right there, okay? You got osteoarthritis when this articular cartilage wears away. All right? That's okay, you don't have to know that. I want you to know where the articular cartilage is right here. Now, I got 2 lines I want to put in here. 2 lines right here. This is where the bone growth occurs, the physis, P-H-Y-S-I-S. P-H-Y, physis. Physis. This is where mitosis occurs. It's where bone growth occurs, okay? The physis itself. Now, you may see some other listings for this right here. The growth plate or something like that, but I'm just going to call it the physis because I have a section of bone on top of the physis called the epiphysis. Epiphysis. E-P-I means above. So this is my epiphysis, E-P-I, E-P-I-P-H, E-P-I-P-H-Y-S-I-S, epiphysis. Epiphysis, all right? That's on top of the physis right here. This is the structure right here. I have an epiphysis on this end also. I have articular cartilage on this end also. I don't need to do that. Now, the diaphysis is the shaft of the bone, the diaphysis. D-I-A-P-H-Y-S-I-S. The diaphysis is the shaft of the bone. In the bone right here is a hollow cavity called the bone marrow. The bone marrow. I want that labeled also. The bone marrow itself. That's drawing and labeling the typical long bone. Okay? Now, they talk to you about the osteon. Let's define osteon. I got to go back to the muscle cell for a few seconds. When we define the sarcomere the repeating structure found in skeletal muscles, the repeating structure found in skeletal muscles. When we understand one sarcomere, we understand all of them. Well, the osteon is the same way. The osteon is a repeating structure found in bone, the repeating structure found in bone. Now let me show you where it is located first, okay? I'll draw this for you. If I were to take a cross section of this bone right here, simply cut it right there. Look at my marrow cavity right here, at the outside of the bone right here. I'll find a grouping of bone cells. A grouping of bone cells. And each one of these groupings right here is called an osteon, O-S-T-E-O-N, O-S-T-I-U-M or E-O-N, either way is fine with me. These are a grouping of bone cells. O-S-T-E-U-M, O-S-T-I-U-M, O-S-T-E-O-N. I don't really care how you spell it. Osteum. How do I have it spelled in here? O-S-T-E-O-N. Yeah, I might get an O-N in. I don't really care. E-O-N. Osteum itself. Now, we've got to blow this thing up and draw it. We've got to blow it up and draw it. So this is one osteon, which is a repeating structure found maybe in the shaft of the bone. We find it in the epiphyses, but it's more organized in the shaft. That's what we're going to concentrate on. We find these things running the length of the diaphysis right here. Okay? Now, this is one osteon that we have right here. Right? Now, you make me two concentric circles. One fairly small from the inside, one large on the outside itself right here. Right? The large one is, excuse me, the center one is the central canal. The central canal. I'm going to label that right there. The central canal. C-E-N-T-R-A-L. C-A-N-A-L. Got the blood vessels to it. It supports the blood, supplies the blood to the bone cells that we have right here. Now, I have some circles. They're not quite circles. They're not quite